Here is a short video showing you how to solve more complex simultaneous equations. Before you watch this video, you should have mastered how to solve simple simultaneous equations, and this moves the technique on. You will always have one equation which is relatively simple and straightforward and looks like it could have just come from a B grade question, in which there are just x's and y's, in other words no x squareds or square roots or anything like that. There will always be another equation which is more complicated because there will typically be an x squared or a y squared or an x times y instead of an x plus y perhaps. Our first step is really the only extra thing that's not obvious compared with topics that you already know. The rest of the whole of this problem is just bolting together things that you know from other areas of the syllabus. So you go to the simple equation and you make either x or y the subject of that equation, and it's up to you which one you use. It's just whichever one looks like it's going to be simplest to get on its own. So here I've moved the x to the other side where it's become a minus x. So when I simplify this, I know that y is the same as 1 minus x. That's all we need to do in this box, in this step. So over here we now look at the complicated equation. This step was all about the simple equation. We start with the complicated equation, and because I got y on its own in this step, it's y that I'm going to replace up here. So every y is worth a 1 minus x. So y squared is 1 minus x squared, or whatever you've got from your equation. Now this has had the effect of turning our equation in 2 letters into an equation with only 1 letter. So from here on, you don't need to use any new maths techniques. You've done all the hard work getting just to this second line in this box. We're going to multiply out this bracket, so 1 minus x squared I've chosen to write out as 2 separate brackets and then do FOIL to work out what they would multiply out to give. And if I tidy all of that up, I've got an x squared from here and another x squared from multiplying out the brackets. So I've got 2x squareds minus 2 lots of x plus 1 equals 16. I recognise that this is a quadratic because the highest power is a squared, and before I can solve them, quadratics must always be equal to 0. So I'm going to take the 16 and bring it over to this side where it will become a minus 16. Plus 1 and minus 16 gives me minus 15. So there is a quadratic which I need to solve in the next step, and that's all I'm aiming to do in this box, to get from the complicated equation down to a simple, straightforward quadratic. So again, once we'd got beyond that second line, all we needed to do in this box was multiply out 2 brackets and tidy up the algebra. Similarly, now we've got down to our quadratic, all we need to do in the next step is to solve it. And you've done that before, so I've chosen to solve it with the quadratic formula. Remember, you must show your method. So show one line of working, putting the numbers into the right places in the formula, and then use your calculator. So this has told me there are 2 possible values of x which solve these simultaneous equations. So now I've got to go back, and for each one of these values of x, I've got to find the corresponding value of y. So I take the simple equation, x plus y is 1, and one at a time I work out what y would be for these 2 different values of x. So if x is 3.28, I put that into this equation. So I get 3.28 plus y is 1. Move the 3.28 to the other side where it becomes a minus. So if x is 3.28, y is minus 2.28. And then I do the same thing here using the other x value. So if x is minus 2.28, and I put that into the equation, move it to the other side, y is 3.28. So here are my 2 pairs of solutions. My xy pair is 3.28 minus 2.28, minus 2.28, 3.28. And what these represent are the coordinates of the 2 places where this graph intersects this graph. So that's why you've got an x and y for each pair. So you may want to pause the video there while you've got this up as a template and have a go as example 2. Okay, so exactly the same steps in exactly the same order. Here is my simple equation, and here is my complicated equation. Hopefully it's quite straightforward to tell which one's which. This one's got squareds and x's times by y's. This one could come from a B grade simultaneous equations question. It looks to me easiest to get the y on its own, because if I got the x on its own I'd have to divide all of the other side by 2. So I get the y on its own and I'm done for this box. Now I take the complex equation and I make use of this relationship here to replace one of the letters in the complicated equation with some kind of relationship involving the other letter. So I replace the y with a 1 minus 2x by using that relationship. I multiply out the brackets. I recognize I'm heading to a quadratic because the highest power is a squared, so I've got to make it equal to 0 by bringing the 10 across, and when I tidy up the algebra I end up with that. That's all I need to do in the next step, aim to get my quadratic. In the next step I solve my quadratic. Now you can solve it however you like, so you could have used the quadratic formula here, but this is such a simple one I chose to factorize it. It doesn't matter either way, both methods will work. So my solutions are minus 5 and plus 2. So I know 2 possible values for the x. So now I use the simple equation to work out what the corresponding values are for the y. So if x is minus 5, then y is 11. And if x is 2, then y is minus 3. So these are my 2 pairs of solutions. So in other words, if I were to draw these 2 graphs on a computer, the points where this graph would intersect with this graph are at minus 5, 11 and 2, minus 3. These represent the coordinates of the points of intersection. Now you should from there be able to go on and try the worksheet.